Help everyone explore new worlds and ideas. Support your PBS station.
HPI is on the move.
Drones. These aerial robots are replacing manned planes. They're revolutionizing warfare by allowing us to see and kill from half a world away. And they're making science fiction a reality. Now, with unprecedented access to drone scientists, engineers, and pilots.
Master armed.
Nova reveals the technologies that make drones so powerful and the breakthroughs that are leading us into the future. Will drones soon replace even the most sophisticated manned planes and become a part of our everyday lives?
It started out as a toy for my dogs to chase.
The worry is that we'll have 30,000 drones crisscrossing the sky, accumulating all this information.
They generate opposition both overseas and at home.
I speak out on behalf of the rule of law.
Now, enter a new chapter in aviation history as Nova takes you inside the rise of the drones.
3, 2, 1.
This is the ultimate melding of man and machine. The U.S. has more than 2,300 manned fighter planes.
Tiger 2, Dark Star pictures.
And pilots like Matt McDonough have long been our heroes.
The best fighter pilots that I've seen are the ones that can make a quick decision when things are happening very quickly.
But a revolution is underway as manned planes are replaced by drones. Are we approaching a time when movies like The Terminator become our reality?
Oh God, it's the machines are starting to take over.
A time when machines fly, think, and even kill on their own. Drones are aerial robots that carry visual sensors, navigation systems,
Target acquired.
and sometimes even weapons. They come in all shapes and sizes and go by a variety of names.
The United States Air Force uses the term remotely piloted aircraft. They are also known as unmanned aerial vehicles, or as the media likes to call them, drones.
Already, the Pentagon relies on a family of more than 10,000 drones, usually to spy, but sometimes to kill. Small enough to fit in a soldier's backpack, the 3-foot-long Raven is the most widely used spy drone in the world. The stealthy Sentinel provided crucial intelligence in the raid to kill bin Laden. The killer Predator has flown thousands of missions since 2001. And the giant Global Hawk can stay aloft and spy for up to 35 hours. The military uses drones to support troops on the ground. The CIA maintains a covert drone program to find and target individuals. The government claims drones have helped to eliminate up to 70% of Al-Qaeda's top leadership. They've been so effective, the Air Force predicts nearly a third of its attack and fighter planes will be drones within a decade.
Planes can fly longer, they can pull more Gs, they can be more precise when they bomb if a human is not in the cockpit.
We're entering a new era when the supremacy of even the most advanced planes is being challenged as engineers take the pilot out of the cockpit. Holloman Air Force Base in southern New Mexico is the largest Air Force training base for operators of remotely piloted aircraft.
My name is Chad. I'm a captain in the United States Air Force. For security reasons, we've been asked to cover our last names to prevent us from potentially becoming a target of any kind.
Captain Chad has flown remotely piloted aircraft in combat for 3 years, and now teaches pilots to fly the world's most famous killer drone. It's known as the MQ-1, or more commonly, the Predator. The Predator has changed warfare, but it's just a hint of what's to come.
Where we are in terms of unmanned aerial vehicles is about the same place we were with biplanes right after World War I. We are at the very, very early stages of realizing what the potential of unmanned aerial vehicles are.
Unlike complex fighter planes that are engineered for speed and agility, the Predator is built for endurance, so it needs to be light and efficient.
It's the weight of a pickup truck or so, about 2,000 pounds, and it's balanced pretty evenly on the wheels. And with one hand here, I can lift it up and set it back down.
The propeller-driven Predator cruises at only 84 miles per hour, and its four-cylinder engine burns about 300 times less fuel than a fighter jet.
I can't say exactly how long it can stay up, but it is possible to stay up over 24 hours.
A typical fighter plane can only fly for about 2 hours without refueling, and short, angled wings keep it fast and maneuverable. But the Predator hovers 5 miles up, often in uncontested airspace, and its long wings maximize lift.
So as you can see, it's got some flex to it.
With no pilot to protect, a remotely piloted aircraft is much lighter and simpler than a manned plane. On a fighter, the pilot's support equipment and ejection system alone weigh as much as a Predator, which in place of a cockpit has a satellite control system.
It's essentially the brains of the aircraft. It gives us the ability to communicate, control, keep link with the aircraft, and navigate it.
The Predator's sensor ball carries daylight and infrared cameras.
We can easily make out people from 5-6 miles away.
The sensor ball also guides the Predator's 2 Hellfire missiles.
From right here, we fire the laser, and the laser spot hits the ground, and then once we fire the missile, this is the seeker, so this seeker will find that laser spot on the ground and travel to that spot, giving us a very precise capability of employing weapons.
When conducting missions, remote pilots work out of small trailers on the ground. They control the Predator by satellite. This link is what makes it possible to take the human out of the cockpit and fly from virtually anywhere on the planet.
It's tight, about the size of a normal shipping container. And a shift, it could be anywhere from 2 or 3 hours up to 8 or more hours, depending on the situation.
From trailers like this, pilots of the Predator and its larger cousin, the Reaper, have killed thousands of individuals since 2001. In this clip from Iraq, a Predator pilot sees 2 insurgents firing mortars towards a coalition airbase. He tracks them and finally shoots.
Flash.
The pilot's role is to support troops on the ground and go after threats while trying to minimize civilian casualties. With such high stakes, pilots like Chad need ongoing training. Today, he'll be flying the Reaper in an exercise 50 miles away in the New Mexico desert.
All right, Greg, you're gonna be my HVI. I have Shadow on station. He's gonna be watching you. You're gonna be on
a group of former soldiers working for a company called Rally Point will run an exercise in which Chad will hunt down insurgents in a mock village.
We'll strike you there. Once you die, stay there, drive.
2 will play insurgents, and 1 will be a soldier on the ground communicating with Chad.
About to take off now, so we're going to push the throttle up. And there we're up in the air.
The training mission offers a rare glimpse into the mechanics of how the U.S. uses drones to support troops and prosecute its war on terror. The goal is to make it as realistic as possible so pilots can avoid mistakes when in battle.
They should be checking in here probably in the next 20 minutes or so. It's going to be an MQ-9 Reaper. Check. If they're at 25,000 feet, which they generally work, we're not going to be able to see them at all.
It takes about half an hour to reach the mock village. Drones like the Reaper can fly on their own using autopilot and preset GPS locations. But the Air Force still keeps human hands on the controls at all times.
People have this concept of either it's a manned plane and the pilot's doing everything, or it's an unmanned plane and it's something out of the Terminator movies. The reality is It's in the middle right now for both the manned and the unmanned planes. Our mind tries to put it in terms of robot or human, but the reality is a mix.
As Chad pilots the Reaper, his sensor operator, Jay, controls the cameras and lasers. On the ground, the fake insurgents enter the village as the Reaper hovers miles above.
Bones 3-4, rally 20, stay status.
Rally from Bones 3-4, we have eyes on the target.
Chad gets direction from the soldier, whose handheld receiver and computer allow him to see what Chad sees. Chad's call sign is Bones. The soldier goes by Rally.
And Rally from Bones, we have 2 packs moving around inside the northwest corner of the compound.
Bones 3-4 from Rally 20, continued shadow.
The soldier directs Chad and Jay to follow an HVI, or high-value individual, dressed in black.
Rally from Bones 3-4, looks like the one individual wearing black is now getting on the motorcycle and departing the group.
Depending on the situation, the decision to kill comes from an intelligence officer who could be anywhere, a battle commander on the ground, or sometimes the pilot.
Bones 3-4 from Rally 20, looks like that personnel is stopping.
Bones 3-4, that's a firm, that's what we got up here.
All right, what I'd like to do is go ahead and prosecute 9-line Bravo 1.
Copy. Master armed.
The sensor operator targets using the laser.
This will be a run against the target under our crosshairs. 10 seconds to release. Sensor, you ready?
Copy.
3, 2, 1, rifle. And Bones 3-4, weapons away. 25 seconds time of flight.
The Predator uses laser-guided Hellfire missiles.
The weapons that can be used operate with an air distance of less than 9 feet. You can put a weapon through a window-sized opening with ease.
5, 4, 3, 2, 1, splash.
Rally to Bones 098 firm, we have splash, standby for PDA.
And Bones Rally looks like good splash.
Copy, lasers off, and Master Arm is now safe.
The efficiency of having a single craft able to find, follow, and eliminate a target like this in real time represents a revolution in warfare.
Let's go back to the middle of the last century. During World War II, it took on the order of months to assemble intelligence from a variety of different sources, whether it be airborne, on the ground, to assimilate that information and then determine what targets might be hit. Then it took hundreds of aircraft and literally thousands of bombs to go out and attack a target using that information that had been developed over a period of months. Today, with the capabilities all wrapped up into one vehicle, the Predators and the Reapers in particular, you can accomplish that find, fix, finish cycle in a matter of single-digit minutes.
Before the Predator, the military had to design separate aircraft for intelligence gathering and attack. Reconnaissance was key, and after World War II, engineers built ultra-sophisticated spy planes. They went faster and higher than ever before to make sure the pilots and the information they gathered didn't fall into enemy hands.
The SR-71 was triple sonic. In other words, it go over Mach 3. Max recorded altitude was 85,200 some feet. And there are several of us that have gone higher than that.
Pilot Tony Bavacqua is one of a select group of men to fly the SR-71, a titanium spy plane built during the height of the Cold War that could take photos of the ground with 12-inch resolution from 90,000 feet. Literally faster than a rifle bullet. Even missiles were too slow to catch it.
I was the first person in the SR-71 get shot at, and it was over Hanoi. You got an airplane that's going 2,300 miles an hour, and it's very, very difficult to even come close. They figure that the missile exploded about a mile below me, and we're in and out of there in no time. Thank God.
The cost of such speed was that the SR-71 needed to be refueled every 2 hours. But there was a slower alternative called the U-2. Bavacqua is one of only 12 pilots to have flown both operationally.
I was very proud of being a U-2 pilot because of what we have done and what we're still doing. It's just a magnificent platform, does excellent reconnaissance.
Still widely used today, nearly 60 years after its introduction, pilot endurance limits U-2 flight time to 12 hours.
It's pretty demanding on their bodies. They have to wear a special high-altitude suit for it, and then it whites them out for a good couple of days. It fatigues them quite a bit to go that high.
Manned spy planes are not only limited by human endurance, they also bring the risk of pilot loss. In 1960, Bavacqua's friend, Francis Gary Powers, was shot down while flying a U-2 over the Soviet Union.
It was a propaganda field day for the Russians.
Powers' cover story was that he was on a meteorological flight.
Frank Powers tried to say it was a weather flight, but there was miles of film. And so it was easy to discern what he was doing.
Khrushchev denounced the United States with every epithet in his vocabulary. He summarily rejected all attempts of the West at reconciliation.
Powers was imprisoned in Russia for more than 2 years, creating a major international incident and clearly demonstrating the need for unmanned spy planes.
It was a development from the pilotless aircraft principle. Guidance was by radio from an accompanying aircraft. After reaching altitude...
As early as World War II, once at altitude, airplanes could be controlled by radio signals after the pilot bailed out. But for decades afterwards, before GPS, drones were limited by primitive autopilots and navigation systems. In the 60s and 70s, drones crashed constantly, including the most advanced unmanned aerial vehicle, or UAV, the Aquila drone, that averaged a crash every 20 hours.
It was a small propeller drone that would fly over the battlefield and gather information and beam it back to you. The problem is, back in the 70s, the technology wasn't ready yet. It was a $1 billion program by the time they got just a couple prototypes.
I was frustrated that the U.S. could not make UAVs really work.
Abe Karam is the father of the Predator.
This is one of 2 small UAVs built in my garage between 1980 and 1983. I was borrowing $18,000 a year from family. That's all we had. Everything was built with the lowest possible technology. We were trying to show that if you design the best you can, then you are going to get performance by design.
On his first prototype, the Albatross, Karam placed the engine and propeller in the rear so they wouldn't interfere with the delicate sensors up front. And the inverted tail is also still visible on its famous descendant.
Down-deflected tails are there to protect the prop, so when it tilts back, it's hitting the skids and not hitting the propeller.
An ex-fighter jet engineer, today Karam designs and builds planes at his company in California. In the 70s, when he started working on drones, he realized that without a pilot in the seat, a whole new world of design possibilities opened up. Other unmanned aerial vehicles of the time were still too closely modeled on manned aircraft.
I said, I don't like what I see. I'm not going to take the engine, and I'm not taking the prop, I'm not taking the landing gear, I'm not taking the computer.
Karam believed that efficiency and lightness were the key to creating an affordable, high-endurance UAV. So first, he gave his craft long wings to prioritize lift over speed.
When you want to be efficient, you want to be like the soaring birds, very long span wings. The albatross is the best gliding bird, is 20 times more span than the cord. And my albatross The UAV Albatross was close to that.
Karam built the Albatross from scratch in his garage. He modified a go-kart engine to burn only 1/10 of a gallon of fuel an hour. And Albatross soon evolved into Amber, a 15-foot-long, 28-foot span UAV with 38-hour endurance. Karam relied on seed money from DARPA, the Defense Advanced Research Projects Agency. Its early investments in artificial intelligence and other technologies led to countless civilian uses and made modern UAVs possible.
In the 1970s and 1980s, with significant DARPA impetus and some DARPA funding, a variety of new technologies emerged, including the Global Positioning System, long-range data links, lightweight computer equipment, and composite materials, as well as satellite communications and digital flight controls. The Albatross, the Amber, were the harbingers of the modern era of UAVs.
We were a total team of 3 people, and we proved a lot of what we wanted to prove. Secretary of the Navy and the head of DARPA, they said, okay, you fly 500 hours, how many are you going to crash? We ended up not crashing any in the 500 hours we did for the military.
Karam's Amber prototype never went into full production. But after a number of incarnations, by the mid-90s, his design became known as the Predator.
Do not handle the missile by the strakes, wings, fins, seeker head, rocket motor, nozzle seal, umbilical connector housing during loading to prevent damage to equipment and or injured personnel.
My UAVs were not meant to be armed. It was really built for the Cold War, when we had the big tactical challenge with so much artillery on their side, so much artillery on our side.
Ready?
With 2 large armies facing off, UAVs could be used for espionage, but not attack. Then, after 9/11, America started targeting individuals.
Now we are fighting non-state enemies, so it starts making sense to arm the UAV, which is not my intention in the beginning.
In October 2001, an armed Predator changed warfare forever.
I was the commander of the air operations against Afghanistan, where we actually used, for the first time, a weapon off the MQ-1 Predator. The advantages were enormous, order of magnitude beyond where remotely piloted vehicles had been just 10 years prior in Desert Storm.
Since this initial strike, drones have proven so effective that the Air Force is now training more remote pilots than manned fighter and bomber pilots combined.
So, play on the scenario.
At Holloman Air Force Base in New Mexico, instructor Major Jason teaches this new generation of pilots.
Adam 03, loud and clear.
The stakes are high when operational, so they begin on video simulators. He invents practice scenarios, programmed using Xbox video game controllers.
Adam 09 from Viking 01, you're cleared hot. Stuff that we can't do in the real plane, I can do anything here, because the world's whatever I want it to be.
3, 2, 1, rifle.
It's a controlled environment, and we want them to learn here, so that way when they do go operational, you know, they've already made all those mistakes.
Pilot, it doesn't look like I ever turned the laser on, so I don't know where the missile went.
How did that happen? If that would have happened in real world, that'd be a really, really bad day.
Unlike fighter pilots who train for a minimum of 2 years, remote pilots learn to fly their increasingly automated drones in less than 1.
The FAA did a study recently that showed that pilots with real flight experience in manned aircraft are actually worse UAV pilots than those that have no flight experience and really come in off the street. You actually bring in a skill set that you don't need and a set of expectancies that you shouldn't have when you're flying a UAV if you came from a manned aircraft. So the Air Force is taking officers off the street with no flight training and putting them through the program, and they've been very successful.
They come here, they never went to pilot training like I did. They're here for a few months, and then they have to go operational, so it happens real fast.
Adam 09, rifle, time of flight, 15 seconds.
And when pilots go operational, despite being half a world away from the action, it all feels very real.
Adam from Viking 01, copy splash.
It's not like a video game at all. There's no reset button, there's no, there's no turning it off.
In real strikes, like this one in Iraq, technology actually allows drone pilots to see more than manned pilots ever have.
Because we have such a long loiter time, there's potential to have eyes on the target that we are going to blow up for hours ahead of time. Then we employ on it, strike the target. And then stick around for another few hours to watch what happens afterwards. You have to stay there and then stay plugged in and stay focused on the destruction that you just caused from your aircraft.
In 2012 alone, the U.S. carried out hundreds of drone strikes across 4 countries. Afghanistan is the only publicly authorized war, while strikes in Pakistan, Somalia, and Yemen are covert CIA operations performed without putting American lives on the line.
The technology has enabled us to set aside some of the risk factors of sending a pilot in harm's way. So it's meant that we've conducted a lot more strikes that would have been more problematic if we were using manned systems.
The U.S. claims drones have decimated al-Qaeda's top leadership while causing limited civilian casualties. But the facts are hard to come by.
We know fairly well how many strikes are occurring. What we don't know is the details, who the targets were, whether they were actually eliminated, or whether some other people were killed, because verification is very difficult.
There are no fully reliable counts of civilian deaths, but some critics claim that as many as 30% of those killed in the broader drone wars are civilians, and that the strikes turn people against the U.S. and violate international law. After more than 10 years of attacks, the U.S. officially acknowledged its use of drones to target al-Qaeda members in April 2012, when presidential advisor John Brennan gave a speech.
The United States government conducts targeted strikes against specific al-Qaeda terrorists, sometimes using remotely piloted aircraft, often referred to publicly as drones.
He was met with a strong reaction.
Hundreds of innocent people we are killing with our drone strikes in Pakistan and in Yemen and Somalia. They deserve an apology from you, Mr. Brennan. I speak out on behalf of the Constitution, on behalf of the rule of law. I love the rule of law. I love my country. You are making us less safe by killing so many innocent people around the world. Shame on you.
Thank you.
It's very critical that the U.S. public understand what is happening with the use of this technology, because it is being done in the name of the United States.
Drone technology enables America to strike virtually anyone, anywhere with ease, regardless of national boundaries.
You've seen this deep controversy that surrounds these strikes in places like Pakistan or Yemen or Somalia, and a whole new series of questions for international law.
The fact that you're not flying a human being across a national boundary still makes it an invasion of a country.
We've entered an era where we are conducting an array of operations using unmanned systems that in a previous generation we would have called war, and we would have treated like war. When you're conducting more than 300 airstrikes into a country, you're conducting the equivalent of at least an air war campaign, but we don't call it that now.
Drones can strike with pinpoint precision, but their visual sensors are limited in ways that can lead pilots to make mistakes.
As they stand now, the limitations they have with the Predator is not being able for the pilot to look around and see what's going on.
When the operator zooms in to see detail, it's like looking through a soda straw, and the pilot loses the broader picture.
These individual little small sensor balls could generally see only a very small area on the Earth, even if you're up at 20,000 feet.
I can't look out and see that maybe there's something else going on outside and around me.
So the crew's grasp of the situation can be limited. And when they zoom in, they sometimes lose sight of key details on the ground. This secret 2010 transcript, obtained by journalists through the Freedom of Information Act, reveals what can go wrong. While supporting forces on the ground, a Predator team mistook a convoy of Afghan civilians, including women and children, for militants. The pilot asks, "Is that a rifle?" The answer is, "Can't really tell." After hours of monitoring, the ground commander calls in a strike. And 23 civilians die, in part because of limitations of the sensors. But engineers are working to create new sensors that can see more in greater detail than ever before.
Today, we've developed sensors that can watch with an all-seeing eye and see an area about the size of a small city, all at one time.
This is the next generation of surveillance. For the first time, we actually have permission from the government to show the basic capabilities. It is important for the public to know that some of these capabilities exist.
Engineer Yanis Antoniadis designed the new sensor, known as Argus. With 1.8 billion pixels, it's the world's highest resolution camera. Argus fits inside this pod that attaches to the belly of a UAV. But because much of the work is classified, we can't see the sensor itself.
Because we are not allowed to expose some of the pieces that make up the sensors, so you get to look at pretty plastic curtains.
Also known as Wide Area Persistent Stare, Argus is the equivalent of having up to 100 predators look at an area the size of a medium-sized city at once. This image was taken 17,500 feet above Quantico, Virginia, and covers 15 square miles.
This whole image is at a very, very fine resolution. So if we wanted to know what is going on in any spot along this image, say near this building at this intersection, we can generate a moving image that shows what's going on in the area.
Simply by touching the screen, Antoniadis has opened up a window showing a detailed area, while still maintaining the broader context.
And everything that is a moving object is being automatically tracked. The color boxes represent that the computer has recognized the moving objects. You can see individuals crossing the street. You can see individuals walking in parking lots. There's actually enough resolution to be able to see the people waving their arms or walking around, what kind of clothes they wear. And you could pick the location of where you produce these images anywhere in the entire field of view.
Antoniadis can open up to 65 windows at once and can see objects as small as 6 inches on the ground.
From even 17,500 feet, the white thing that you see flying around is a bird.
Argus streams live to the ground and also stores everything, 1 million terabytes of video a day, which is the equivalent of 5,000 hours of high-definition footage.
So you can go back and say, I would like to see what happened at this particular location 3 days, 2 hours, 4 minutes ago, and it would actually show you exactly what happened as if you were watching it live.
To create the world's highest definition camera, Antoniadis needed to design a new imaging chip. But DARPA, the project's funder, wanted to move fast and keep costs down. So he borrowed technology that most people have in their pockets.
Inside this cell phone, we find a tiny little camera. So if you were to take off the majority of it, you'd be left with an imaging chip. If you were to take 368 of these and make a big mosaic out of them and start shooting images, now you have Argus.
Unlike the Predator camera that limits field of view, Argus melds together video from each of its 368 chips to create a 1.8 billion pixel video stream. This makes it possible to zoom in and still see tremendous detail. Whether Argus has been deployed in the field is classified.
I'm not at liberty to discuss plans that the government, but if we had our choice, we would like Argus to be over the same area 24 hours a day, 7 days a week. That's not very easily achievable with manned platforms. This is where UAVs come in, and they're absolutely the perfect platform.
Argus may be mounted on an armed UAV like the Predator, a long-range platform like the giant Global Hawk, or a development craft called the Solar Eagle that may someday stay aloft for years at a time.
The U.S. Air Force right now has the ability to archive every single video that comes off of every single UAV. We're moving to an increasingly electronic society where our movements are going to be tracked.
While technologies like Argus are expanding the reconnaissance power of UAVs, unmanned aircraft remain vulnerable in other ways. The Air Force's large drones still crash more often than manned planes. The $100 million Global Hawk is nearly 3 times more likely to crash than the U-2 it was designed to replace. Even if there's no pilot to lose, when a drone goes down, it can still be a problem.
It doesn't take a thermonuclear brain surgeon to figure out that if you are operating a highly advanced, technologically capable system, that you'd prefer not for it to fall into adversary hands.
In 2011, an American spy drone, the RQ-170 Sentinel, was lost over Iran.
There was a problem with the aircraft, and it landed in an area it shouldn't have landed in, and that's about all I'm gonna say.
The Iranians claim they hacked into the drone's control system and took over the craft. And in theory, it is possible to take over any computerized system.
You could never call up Maverick in his F-14 if the movie's, Top Gun, and you say, Maverick,
talk to me, Goose.
Recode all American jets as Russian jets. Tom Cruise would have, laughed his weird cackle and said, no way, man. With a computer, you can do that. Either jam it or even more so, co-opt its operations. And it's a whole new era in war. Opens up a lot of new possibilities and, of course, huge new dangers to think about.
Why the Sentinel went down remains classified. But experts point out that drones often crash for very basic reasons.
UAVs sometimes aren't that smart. Their self-diagnosis isn't all that smart. And by the time they have a problem, it's too late. You lose the link, lose power, and you're gone.
Control can be lost for a number of reasons. When Reaper pilot Chad simply banks too sharply, he loses the satellite link.
Uh-oh.
The picture freezes, and he's momentarily flying blind.
That was me turning.
He quickly levels the craft and restores the link.
I was turning aggressively, and it had trouble keeping up the satellite link.
There is a degree of vulnerability involved with remotely piloted aircraft that have a command link, or they're actually operated by operators, that you can overcome by having a human in the cockpit.
Dark Star, football.
If for some reason I all of a sudden hear an increase in airspeed, I start to feel a roll, and I'm not intending for that to happen, well, something is going wrong, and I now need to make sure that I'm doing what I need to be doing.
Unlike manned planes, drones depend on control links that can be lost, or potentially, as may have happened with the Sentinel, even taken over by the enemy. But what if a craft could operate on its own, free of any links, and even make its own decisions? In a lab at the University of Pennsylvania, Vijay Kumar is funded in part by the military to create autonomous drones that don't need external links, and like us, can sense their environment.
What you see on this robot are these two chips here, which are essentially rate gyroscopes. These play the same role as the semicircular canals in the human body located near the ears, which essentially tell us orientation. So the rate gyroscopes that are on board can actually measure these angular velocities at thousands of times a second. This chip here is the accelerometer, and this allows the robot to sense accelerations in the lateral direction. So these are analogs to the otolith organs that measure acceleration in the human head.
When a human pilot feels an unexpected change in acceleration, he knows to adjust the aircraft.
And the robots do exactly the same thing.
The sensors adjust the craft by changing the relative velocities of the rotors and allow the drones to follow a leader with precision.
A fundamental problem in coordinating multiple robots is the ability to maintain formations. What a robot has to do is determine where its neighbors are and figure out what the relative position is, and then monitor that relative separation very carefully. You only need to tell one robot how to move, and the other robots essentially maintain formation by just keeping a specified relative distance. In the figure eight, they come within inches of each other, so they have to combat aerodynamic effects from their neighbors, and they have to have very, very precise control. And all that is done autonomously.
The precision of the robots allows them to do some things more quickly and accurately than human pilots can, like predict the movement and the shape of an object and adjust accordingly.
In terms of acrobatics, I think it'll be hard to beat what a robot can do. The neuromuscular system in the human body, there may be delays of the order of 80 milliseconds to 200 milliseconds before you actually take an action in response to what you see. Well, robots have this unfair advantage. They can do these computations hundreds of times a second. So your delays are of the order of a millisecond and perhaps even less.
In the lab, the drones communicate with a central computer that uses motion capture, an optical system that tracks silver reflective markers on the robots and tells them where they are at all times. But soon it may be possible to cut the cord. And they've already developed another autonomous drone that can go anywhere on its own.
The holy grail is to do all of this without any kind of external sensing, without GPS. And in principle, we can do it. These bigger robots actually rely on observations of external features to tell them where they are in the environment.
This drone carries a laser rangefinder that determines distance to obstacles and a depth camera that reveals 3D information about the surroundings.
They carry on board the processing power, the sensors that are necessary to look at the environment, to reason about the environment. So they can take their relative location and the location of the features to build a three-dimensional map. Well, I'd like to see this technology being used for humanitarian purposes. Imagine there's a 911 call from the building. I think we'll soon have the technology that enables, let's say, 20 UAVs to just swoop through the building and within a minute find out who's in each room and then communicate that to firefighters who are waiting outside. But any technology that you develop, there are always people who are going to use it in ways that the designer never intended them to be used.
And the key components of drone technology are already available to virtually anyone.
Over there. I got into the hobby about 4 years ago. It started out as a toy for my dogs to chase. I'm pretty obsessed with the hobby. I am currently single, have been for 30 years. No kids. I just live here with my 3 dogs, and I get to spend nearly every night and every weekend working on these things.
Corey Brixon of Orange County, California, is one of tens of thousands of drone hobbyists across the country.
The basic quadcopter is about $500, which is the frame, the motors, the speed controllers, the electronics that you need. This is actually the GPS sensor, and that's sending the signals out to the satellites. The cameras, as small as they are, they're high-definition footage.
Like the Predator, Corey's quadrotor has a programmable autopilot that uses GPS to navigate. He can set locations, altitude, and speed so the craft can fly autonomously. Corey flies for fun, but drones, small and large, are increasingly used domestically for more serious purposes. The Border Patrol searches for illegal migrants with Predators. Police departments are turning to smaller drones for reconnaissance. And thousands of individuals use them for their own, sometimes political, ends.
We don't consider ourselves to be animal rights activists. We're investigators. Some of our targets are the pigeon shooters in Pennsylvania, so we had the copter up filming what's going on. There were a couple of shots
and it's slowly losing altitude. And then it takes one more shot, and it's down in the trees. You can hear the shooters start cheering and laughing and all that kind of thing. What they didn't know is that we had more.
This incident is the first known shoot-down of a domestic drone, but it may not be the last. The spread of drones has raised concerns about privacy and even led one senator to propose legislation limiting domestic use.
I think anybody that can use a device to peer into your activities, even if it's from the air outside your window or the air above your property, I think there's a right to privacy, and I'm all for making sure that all these drones don't come back from Afghanistan and Iraq and get put to purpose here that isn't consistent with our constitutional bearings. The worry is that in 2 or 3 years, we'll have 30,000 drones crisscrossing the sky, accumulating all this information.
It's a game changer, but it's not just an American revolution. There are more than 55 other countries right now that are building, buying, or using military robotics, particularly in the air.
Iran recently announced it has its own armed drone with a range of over 1,000 miles. It's not known whether any of the technology was adopted from the lost U.S. Sentinel. But in the drone's arms race, the U.S. is constantly developing new technologies, like a small flying camera with a twist called Switchblade.
The Switchblade will launch out of this tube, and the wings, the tail, the propeller will all spring open. That's why it's called Switchblade. And so when the operator finds the target by looking into the viewing screen, he'll then send a command to the Switchblade that'll enable the Switchblade to basically hone in on that target and detonate its explosive charge upon contact. It's a tool that our customers are very excited about, and it's a tool we think will protect our forces and help save innocent lives.
Switchblade's already been deployed, and a killer drone that may someday replace a manned fighter is on the horizon.
And it's really about a decade ago, some folks got together and they said, what if we want to put unmanned aircraft on an aircraft carrier? How do we do that?
This X-47B prototype is the world's first tailless fighter-sized drone. But it's still a year or two away from its first goal, to take off and land on an aircraft carrier.
We're maturing the technology required to take this unmanned vehicle to land on the flight deck autonomously. We're focusing on the mechanics of landing the aircraft, where you have a predetermined position that you're targeting to, and the aircraft can react very quickly to changes in that environment to put itself on that pre-planned position. The system has a lot of sensors, a lot of instrumentation on it, so it knows how all of its subsystems are behaving. It knows how its engine and all of its control surfaces are performing at any time. It'll turn where we expect it to turn, it'll come back when we expect it to come back, and it'll land on the runway that we planned.
Drones are no longer just eyes in the sky, and someday UAVs like the X-47B may be involved in sophisticated attacks alongside manned jets.
It's the idea of the mix, the team working together. That's probably the future. You won't see every plane on the aircraft carrier be one of these. So right now the vision is, oh, we'll just have one or two. But when they get them and maybe they prove more useful, then it may be, well, we don't want one or two, we want a squadron. It's a lot like if you look at the first use of mechanized forces. Originally it was lots of horses and just a couple of trucks and tanks, and then you saw things change and change and change over time. We'll probably see the same thing happening with robotics.
As drones like the X-47B mature, they'll become more autonomous, likely conducting bombing runs, then more complicated air-to-air operations. Even as policymakers debate the rules of engagement for drones, technology is moving forward toward a time when drones might operate with intelligence that more closely resembles our own. But for now, they can't do what a pilot can.
When you get an aircraft like this over hostile territory, you'll have potential targets or threats that will pop up unplanned. So what we haven't done yet is develop the technology that would then react to those unplanned targets or threats.
Thank you very much for coming to Pax River today.
I think UAVs of the future will certainly be able to exhibit increased levels of autonomy. But I think if you were to ask most autonomy researchers or most AI researchers about whether the rise of the machines type scenario is a real concern, their response would be, we should be so lucky. And in fact, if we could get little slivers of that kind of adaptive and cognitive capability into systems, that would be a very significant breakthrough over where we stand today.
Angry T-class check. I've flown about 2,000 hours, and the missions that I've flown seldom go as planned. There's a lot of pieces that you cannot plan for.
Nothing replaces the human being in a tactical environment, saying what to do next and why not this and why not that. An Airbus 320 with 150 passengers goes into a flock of Canadian geese and needing to land. I can't do it. I'm going on the Hudson. You want to be in a robotic 320 in that situation? Or do you want Sorenberg to land you? Because you can't anticipate everything.
This ability to respond to the unknown may be the final hurdle if drones are ever to fully replace manned planes and start making decisions on their own.
I think we're far, but let me say, I am the last guy who says, impossible.
As human ambition drives innovation forward, the only thing that's certain is that the Predator and other drones of today are nothing compared with what's to come.
Ultimately, DARPA's mission is the creation and prevention of strategic surprise. So if we are successful, we will all be surprised.
Historically, you look at when the Wright brothers first flew in 1903. 100 years later, we were actively flying remotely piloted aircraft. So we're kind of on the ground floor now. There's nowhere to go but up.